So tonight we're going to talk about what a command bus is. A little bit about me. I work as a machine learning architect for a company called Iron Mountain. Typically, I would do the whole hand thing and show you that I'm from Michigan, but seeing as how this is a Michigan user group, I figured that was kind of pointless. So I've been a professional developer for a little over 10 years, doing like Windows Forms, web, mobile stuff, mostly in the .NET stack. And more recently, I've done a lot of cloud and machine learning. And that is more in Python. But I also do a lot in C# as well. What is a bus? Right, so this is kind of an analogy I came up with that I want you to kind of use or kind of understand when we start talking about different buses. I want you to think of a bus as an expressway, right? So if you think about an expressway, you have on ramps, you have off ramps, you have messages or cars that go on and off. So that's basically what a bus is, right? It's a transport mechanism that you put messages onto and then you take messages off of, right? So let's talk about a little bit of so some of the kinds of buses. So you know we have like motor coaches and we have short buses. Well, these are not the kind of buses we're talking about. This is more or less just to be funny. So let's talk about where the concept actually comes from. So the concept itself comes from the concept of a computer bus, right? So if we think about like computer architecture, we know that we have a CPU, we know that we have memory, we know that we have the PCI bus, which would be things like our video card and external card. We'd have memory. And the way that data goes from, like, say, the CPU to the memory to the hard drive is along a bus, right? So that's where the concept of all this stuff really comes from. So I want you to keep that in mind as we talk about the different types of buses. And if you guys have questions, feel free to either go unmute and interrupt me, or I also have the chat open. You can throw a message in the chat and I'll periodically be looking at that so that we can see if you have any questions. Okay. So there's different types of communication buses that we're going to look at, and I think it's important to look at different patterns and different strategies for buses in order to understand what these different things are, because you're going to hear a lot of terms when you start looking at buses. You're going to hear command bus, you're going to hear enterprise service bus, you're going to hear message bus, all that kind of stuff. So we're gonna break it down and explain to you what those different pieces are and where they would fit into your applications. The first of which we're going to look at is what's known as a message bus. So if you look on this side, can you guys see my mouse? Okay, so on the left side, you see that we have producer applications, right? So this might be like, let's say application 1 or it has to talk to microservice 2. Then one of the ways that you can kind of decouple these systems so that they don't have hard dependencies on one or the other is you can facilitate that communication by a message bus. So what you would use is use a protocol like AMQP. You would use that to write a message onto the bus, and then that microservice would then listen on that queue, right? So that way, if you ever need to change from app 1 going from microservice 2 to microservice 3, all you need to do is have microservice 2 stop listening on that queue, and then microservice 3 start listening on the queue. And now I don't have to touch anything with app 1. I don't have to rewrite any of my code. So this decoupling is how I can have different services and different applications in my environment talk and share information while still maintaining that very loose coupling. Okay, so any questions on that so far? Oh, mouse cursor is very small. Okay, I'm not sure if there's anything I could do about that, but anyway, so were you able to follow along with what I was saying?
Yeah, I wonder, could you, what is AMQP? I'm not familiar with the acronym.
AMQP is a protocol. I forget what the A is, but it's message queuing protocol. And this is the protocol that's used by RabbitMQ. to allow you to write to and read from a message queue. So for now, just think of those as protocols. And one of the important things to know is notice how everything on both sides all use the same protocol. Okay, that's going to be really important here in just a minute. Okay, so again, this type of buses and this type of messaging is across applications. This is inter-communication of your applications within your ecosystem. Okay. There's different platforms for doing that. There's cloud-based ones such as Azure Service Bus or AWS has simple queuing service. There's also services like RabbitMQ. To a much lesser extent, there's like the MSMQ, which I would highly recommend don't use. Advanced Message Queuing Protocol. Perfect. Thank you, Sam. So these are the different types of implementations you could use if you want to do this type of thing where you want to have two applications talk to each other without having to use like HTTP or something like that, where they're hard coded, where one app is hard coded to another. This is a way of decoupling that. Okay, so the next thing we're going to look at is the Enterprise Service Bus. So if you look at this, it's exactly the same thing as what we just looked at with the message bus, where we have applications talking to other applications. The biggest difference is notice how there's different protocols coming in now, right? So the only difference between a message bus and a enterprise service bus is the protocol you use to put the messages onto and off of the queue. So for example, I could use, for app 1, I could use AMQP, which would be Rabbit, to put the message into the service bus. And then in service 2, I could take it off using HTTP. So that's the biggest difference. And this is one of the big things that you'll hear, like everyone's like, oh, you need an enterprise service bus, enterprise service bus. It's like, well, do you? Sometimes you do, sometimes you don't. If you're in control of all the applications and you want to put them all under the same protocol, then you don't need necessarily an enterprise service bus. If you need to support a lot of different applications using a lot of different protocols, that's when you would go to that. Okay, so any questions about the difference between an enterprise service bus and a message queue? Okay, so another thing I want to point out here is if you look in the middle, there's the bus itself, right? So the bus itself would be the dotted box. And then you can see the messages that get put in there. So a producer would produce a message. Let's say app 1 wants to talk to microservice 2 again. The app 1 would put a message on that bus that would then be picked up by that microservice 2. So the first one can be a message for microservice 2. The second one could be a message for microservice 3, et cetera, et cetera. Okay, so it's basically messages that you're passing, and there's routing that happens with the message itself, and you're just basically putting them in this bus. And we'll look more at this when we get into our samples. Security across internet is built into these buses. It depends on which platform you use. If you're using one of the, let's say you're using one of the message queuing platforms, like the SQS from AWS, that definitely has a lot of security and stuff built into it. And a lot of it depends on how you utilize it. And also to the level that it has of security depends on the implementation rather. So for example, with enterprise service buses, each of them are gonna do different things, but in general, they do have security kind of baked into it, so that you can lock it down and make sure that you're only allowing certain people to send like requests and things like that. What did you mean when you said no general purpose?
On that, I was answering the question. Were there any questions? No. And
okay.
It appears to me to be general purpose.
Gotcha. Okay. Sorry. Okay, I just read that wrong. All right. So some common enterprise service bus platforms are like MuleSoft, Neuron, ESB, and NService Bus. So these are a little bit outside the topic of what we're going to talk about today. So I want to give you guys the information and point you in a direction that if you need to do these type of things, these would be the technologies you want to look at depending on what fits right for your enterprise. But the next thing we're going to look at is Intra Communication Bus. So this is where different parts of the same app will communicate with other pieces. So basically, it's the same exact concept as what we just looked at with the message queue and the message bus, but now it's for within the process. It's within the same application. Okay. So this at a very high level is the basic pieces of a command bus. You have a command, which is data that you want to pass. So it's basically the structure that determines what the message is going to look like that you're going to pass into the bus. And then that bus takes the message, passes it along to a message router, and then that finally gets passed off to a handler. So we'll look at what these pieces mean and how this actually works here in just a second. But I wanted to kind of give you a high-level overview of what the different pieces of the system are and kind of how they flow together. So we're going to create an instance of this command. We're going to send it onto the bus. The bus is going to take that, pass it to its router, and then from the router, it's going to then call the handler. So let's go ahead and build one. And this would be where I have to switch screens or switch sharing now. It's pausing screen sharing. All right, so how do I unshare and then reshare? All right, 1 second, let me figure this out. Okay, here we go. Stop sharing. And now I need to share screen. There we go. Okay, let me know when you can see me again. See my screen again. All right, 1 second. I don't know what it's doing. It's like acting up. Can you guys see me?
Not yet.
I don't know why. I don't know what is this thing doing.
Yeah, exactly.
Skip preview, share.
Does that screen button play any role at the bottom?
Yeah, so I click the screen button. It pops up. I click the screen I want to the application I want to share. I click share. It goes away and then doesn't actually do anything. I don't know why this thing's doing this. All right, let me try opening this in instead. All right, let's try this. Okay, can you see me now?
I can.
Yes.
All right, cool. All right, I don't know why, I don't know what's going on. It was not letting me share Visual Studio, so I'll just do it in Visual Studio Code then.
All right, it's a black screen and with white characters. A little bit difficult to read.
All right, give me 1 second. All right, get out of the way. All right, view appearance, here's that. Preferences, there we go. I'm trying to think, there's a quick way of switching that, isn't there? Does anybody know how to do that real quick? Get out of here. Are you gonna let me close this now? What the heck? How about if I zoom in? It's not gonna let me zoom in either. What the?
Might work.
I don't know why it's not letting me zoom in either. What is going on with this thing? Here, give me 1 second. Let me try. Let me see if I can share this again. Because ideally, I like to show it in Visual Studio. I don't know why it's that. I don't know. I've never had these problems before. It's really weird.
The live demo gods are not on your side tonight, Brian.
Yeah, I know.
Well, the other thing is that sometimes the communication software intervenes in some way.
I don't know. This is so weird. I don't know. I've honestly never had problems. It's weird. I mean, we just did a global AI thing not too long ago. Okay, so you can see me again then, right?
Yeah, it looks the same as it was before.
Yeah, I know. Does anybody know real quick how to increase the font?
Should be 2 buttons on the side for increasing your view. Everyone has that.
Right.
Are you talking about in you talking about in the GoToMeeting?
Yeah, inside the presentation pane.
Presentation pane. I see drawing tools. That's how I want it.
Right. If you want to
For users, they should see a 2 buttons on the side that allow them to zoom in and zoom out. That's for viewers. I'm not sure if the presenter would see that.
Yeah, I see the button you're talking about. It's just collapse. It's not changing the size.
Brian, you can try changing the theme. So if you go into File, Preferences, Color Theme, then you can choose, like light.
There we go. That's what I was looking for. Thank you. Is that easier to read?
It's easier. It's obviously it's easier to read, but the font is so small that it's not interpretable. If you can increase the font, I don't know what font size that is, but you might want to go up 3 or 4 steps.
Yeah, let me see if I can do it in here.
I don't know. Select all.
I'm sorry.
Select all, because I don't know if that's relevant.
Oh, here we go. Let's just try this. Is that better? Is that better now?
Yeah, that's good.
Okay. All right. Sorry about that. Yeah, like Steve said, demo gods. All right. So, anyways, let's walk through this, and I'll show you I'll walk you through how to actually create one. So the first thing we're going to start with, if we look under here, is we're going to look at a couple things here. The first thing I want to do before we get into the command bus is I want to walk you through a little bit of the architecture I have going on in this particular project. So obviously it's a command line project, so we're going to have our program.cs. We're going to have our contracts right here. So this is just going to be a customer object that we're going to work with. We also have repositories. So this is be our interface, and then these are our methods. So everything that we're using in this example is just going to be an in-memory database, if you will. But what I want to show you is how you can actually use the command bus and how we can actually build one to actually perform actions against a database, if you will, without actually having to have a database. And then under the composition, so this is a, so for this, I'm using like dependency injection and inversion of control. In this case, I'm using ninject to give me a kernel, which I load all my stuff against. And then I'm using a service locator pattern, which is fine as long as it's a console application. And then like something called a composition root. So what this basically means is I have a composition root, which tells me how am I going to compose all the pieces of my DI container together, right? So it's going to create the container. It's going to load in any modules for it, and then it's going to allow me to retrieve instances of things out of it. So if you're not really familiar with dependency injection and IOC, what you're doing is you are inverting the control of creating certain classes and objects to this container, and then you're letting it maintain the life cycle of it. So for example, here you can see that I'm binding my command bus to the instance of my command bus, and I'm doing it in singleton scope. So what that means is when I tell Ninject to do this, it's going to create an instance of my command bus, which we're going to look at here in a second. And then it's going to put it in, it's going to create that instance and put it in a scope so that it only ever creates one for the entire lifecycle of the application. So the reason why I'm showing you the DI and IOC stuff, even though it's a little bit outside the scope of this talk, is because this is how you typically wire things up to make them work within your application. So is anybody not familiar with the concept of DI or IOC that wants me to go a little bit more in depth with it, or is that sufficient?
I guess I would just ask generically, what is it, outside of just the Microsoft world?
Okay. So what is DI and IOC outside? Okay. So it's basically allowing you to build up your application that has all these dependencies. So what dependency injection is, and maybe I should start there. Let me start with the bus itself. So if you look here, I have this command bus class, right? And what dependency injection says is any dependencies that this class needs, I'm going to inject into the constructor. Okay, so that's the dependency injection part of it. Okay. So now think about how I would actually utilize this class, right? So I would have to say, I would have to say something like, var, oops, let me just do that. I'd have to say something like var command bus equals new command bus, right? But now command bus needs a message router, right? So then I'd have to come here and say var message router equals new message router. And then I'd have to pass that in, right? So you with me? And,
Yeah,
then I can utilize that to do whatever I want, like to
generically object type system.
Say it again.
Let's say generically an object-like system.
Generically, system.
Well,
yeah.
C++, Java, yada yada yada, all of them out there.
Sorry, I'm not sure I follow.
Well, what I'm saying is, I'm looking at the syntax. I said, gee, could you write something like that in C++? Yes. Could you write something like that in Java? Yes.
Yeah. Yeah, absolutely. Yeah, so this would be traditionally how you would do that, right? How you would create that thing, and then in order to create this, I have to inject any dependencies I have, right? So now I would first have to go create instances of this, and if I had like 10 dependencies, I'd have to go create those 10 objects just to create this one object. Okay, so let me show you what that looks like if we use the dependency injection stuff, or the Ioc container now. So now what I would say is composition root dot get I command bus. Okay, so now what this does is based upon the bindings that I specify here, like I specify command bus, I specify message router. So the way I want you to read this is when is like this. When I ask for an I command bus, I want you to give me a command bus instance that you're creating and maintaining. When I ask for a message router, I want you to give me a message router. Okay? So now back in my code, all I simply need to do is do this one line of code. And then if I had 10 dependencies that went into this command bus, I only have to just say, give me a command bus, and I let it handle all those dependencies for me. So its responsibility, the container's responsibility, is to create and maintain instances of objects, and it will wire up all those dependencies that are required for you. Okay, does that make sense?
Right. It's a composition kind of thing.
Yes, exactly. It's a composition. Yep. And that's why I call it composition root, is because I'm composing my application so that all the dependencies and stuff that I need, I'm just injecting in and I'm letting the container handle all that stuff. All right, so now that we understand that, let's get into looking at the different components of a command bus. So if you think back to the diagram I showed you, the first thing that we have is a command. So in order to have a command, let me see right here. Yeah. So in order to specify that something is a command, I have just a placeholder interface, right? So I just say interface I command, and then this is what will let me know that whatever object I create, the difference between this and a normal POCO is that this I can treat as a command now. Okay, so that command interface is just a placeholder. There's nothing on it. And then this will be what tells the router how to wire this thing up into so that it will go to the correct handler. Okay. So any questions on that so far? Hopefully I'm not confusing anybody.
No, it's a generic, right? Like.
Yes. Yeah. Yep. So the way that a command works is that commands have all the data that need to happen in order for an action to happen. So we'll talk a little bit more about commands versus queries and stuff like that in just a little bit. But basically, a command is something you want to do to data, and a query would be just reading data, right? So if you think about your CRUD, commands are your CUD, and your queries are your read. Okay. So in this case, and when you create commands, you want them to be very specific and only do one job. So I don't want a update customer command per se. I want an inactivate customer command. So what I'm going to do is I'm going to take in, so I need to pass it the customer that I want to manipulate, which is all I'm going to do here. And then when this thing gets passed into the handler, is actually going to do something using this data. Okay. So again, going back to the bus is very simple. It just takes in a router, and then it takes in my command, and then it's just going to pass it to the router, or the router is going to find the handler that it correlates to, and then actually invoke that handler. So what a handler is, and I should show you the actual handler. sorry. So what a handler is it's going to be something that takes that object, that command object, and then it's going to do the actual work. Okay. So when you yeah, so basically what you're doing, and this will make more sense here when we look at how this gets wired up and how we utilize this. But basically what we're doing is we're creating, we're creating an object of data we want to manipulate, and then we're sending it to this handler to manipulate it without us having to wire up and send all these dependencies around. So it'll make a lot more sense here in just a minute. But so let me continue on. So that's our bus. We looked at what handlers are. The router itself just does some ninject. So in this case, I'm using ninject. So it just does some ninject trickery to find the associated command for the handler. So the general rule is a command and a handler are a one-to-one correspondence. You will not have a command go to more than one handler, and you will not have a handler that handles more than one command. Okay. So now let's take a look now down here and let's kind of put this stuff together. This will make a lot more sense now. So what I'm going to do is I'm going to retrieve a customer from a database. So I'm just going to say, hey, go get me my customer repository. In that repository, get me customer ID 1. That's going to give me back a customer object. You can see it's my customer. Then what I want to do is I'm going to say, hey, command bus. So in other words, this is how I get my command bus. So give me a command bus. And then what I'm going to do is I'm going to send a new and activate customer command. And then this will automatically figure out what it needs to do to wire up and handle all that routing stuff for me so that I get from my command object into my handler. So this is where this becomes really powerful and why you can have a lot of things very decoupled, because instead of me having to take in a dependency for everything I need to do in order for this action to happen, I can just put it on the bus and then let the bus route it to the proper spot. And then my handler would have everything that I need to have, whatever dependencies are, right? So if my handler takes in a customer repository, notice how I don't pass the repository on the bus here, right? So I just say, hey, here's an object, pass in the customer, take that, shove it on the bus, and then let the handler figure out whatever it needs to do. So the handler is the one that, so the command is the data that you want to pass into the handler to do something, and the handler is the actual code that does something. Okay, does that all make sense? Hopefully I'm explaining that at a good way so it's easy to follow.
That's a rough idea. The only thing might be missing is what happens when you add in all the security issues like access and authorization, et cetera, et cetera. But that's another layer.
Yeah, so let's do you mind bringing that back up when we get down to talking about Mediator?
Okay.
Because there's some cool stuff you could do with Mediator on that. So all in all, does this all make sense so far? Like how this works, what the different pieces are. Any questions before we move on? Okay, cool. So yeah, so if you look here, like you can see, like I said, like we have some boilerplate code where it's all generics. Like this code is 100% completely reusable from project to project, right? So in a lot of ways, it doesn't make sense to have it just within this particular application I'm trying to use. What makes more sense is to actually bring this out and use it in a way so that this stuff could just include it as a NuGet package, and then you can utilize it. We'll look more at that a little bit later, but what I wanted to do and what I was hoping to show with this is I wanted to show you the different pieces, how you can build it, and what's actually happening behind the scenes. So that way, when I go to use a framework like Mediator, it's not completely foreign to you. Okay. All right. So now what I need to do is I need to try to switch back to my presentation. Yay, it worked the first time. So what I wanted to point out with that too is the thing that we looked at was commands, right? Commands, as I alluded to, are just the create, the update, and the delete, right? These are things that are actually changing state of the machine, of your application, right? So when you look at a command bus, you're typically going to have it divided out into 3 different categories. You're going to have commands, you're going to have queries. So again, your creates, your updates, and your deletes. Your queries are your reads, and then events are just notifications you want to pass around the system, right? So an example of an event might be, you know, when a customer was updated, I want to throw a customer updated event. And then what I want that code to handle is that I want to take that and maybe write it into you know, another system, like pass that data along to another system, right? So an event could be how I would you know, take it from, like, you know, one application to another by using that message queuing that we talked about earlier, where I could pass a message off to other systems. So this is a really cool way that you can have kind of like your one system, you know, one application as your source of truth for your data, and then you can tie into all these events so that you can have all these trialed applications that listen to say, hey, let me know when a customer was updated. So now I don't have to go query the database. I don't have to, you know, tie into this other application. Instead, I just get the notification and whatever information is applicable to it. Okay. And then again, just like we saw, you know, with commands go to command handlers, events go to event handlers, and queries go to query handlers. So one of the things is when we talk more about Mediator, Mediator doesn't differentiate between commands and queries. So these in both cases would just be what's called iRequest. So we'll look at that more in depth too when we get there, but I just wanted to mention that now. So let's talk a little bit about why we actually care about this kind of stuff and why, what a command is, what a query is, and why we actually care, right? So a command is an operation that affects some change to the system. For example, setting a variable, such as what we did where we update the customer to set them inactive. It's an operation that intentionally creates a side effect. So in object-oriented programming, the command pattern is a behavioral design pattern in which an object is used to encapsulate all the information needed to perform the action or trigger an event at a later time. This information includes the method name, object that it owns the method and values, and whatever other parameters. So what that means is that, so just like with message queuing, you can kind of think of that as like asynchronous processing, where I'm going to put a message into a queue, and at some point in the future, something is going to pull that message off and process it, right? So it could be, you know, immediately, or it could be like 2 years from now. So think of it like this, and this is where kind of, this is kind of the canonical example. Think of it like Amazon, right? So I want to go buy something on Amazon. Well, if you think about all the steps that would have to happen in order for an actual transaction and delivery and stuff to happen, there's a lot of steps, right? I have to, you know, I have to accept the order. I have to process the payment. I have to check inventory. I have to set up the billing. I have to set up the delivery, right? So back in the day, Amazon used to do that all in real time, right? And as a result, you know, things would, you know, sometimes be out of stock or whatever. Like it would have to do all that stuff, and your checkout process would be really slow. And if you look at how Amazon works now, if you look, the checkout process is really fast. Why? Because the only thing it does is record that you want to buy these things, and then it'll go out and check inventory. Then it'll go out and figure out the delivery. Then it'll go out and charge your credit card, so that now they have these things very, very decoupled, where now they have a message that passes to these different systems. And that way, you know, they don't have to, you know, for example, if they don't have inventory of it, then they're not billing your credit card and having to do a refund. So that's where they kind of optimize their process, and that's the kind of the thing you can do with this kind of thing, is where you can pass messages across your application or within your app or across your app, and then you can have different events be triggered from it. Okay, does that make sense? Okay, so this is the command pattern. The next pattern we'll look at is command query separation. So command query separation is a principle of immersive computer programming designed by blah, blah, blah. So it states that every method should either be a command that performs an action or a query that returns data to the caller, but not both. Okay, and this is kind of like, they take a hard line in the sand where you should have, your handler should only do one of two things. It should either manipulate state or it should return state. And this is kind of more like a purist view. We could talk more about this when we get into some of the later examples. But basically, it's all on how you want to utilize it. And this is not like necessarily a hard line in the sand. But it's important to talk about commands and queries and the separation of commands and queries, because if we don't understand these concepts, then the next thing we're going to talk about, which is the true value of really doing a lot of this, is going to kind of be lost to you, okay? So with that, what I want to talk to you about is command query responsibility segregation. So this is a pattern in which you use a different model to update information than the model used to read information. Okay, so a lot of people tend to equate CQS and CQRS to be the same thing, but technically they're not. CQS is more about the pattern of you need to have a hard line in the sand where your commands only manipulate state, not query or read state, and your queries only read state and never manipulate state. But in reality and in practice, you're going to find that there's a kind of a gray line between there. But this is the biggest part of that. So I want to open up the question: why would we want to separate our update information from our read information? Does anybody have a clue as to why we would want to do that? Why we care?
Simple sequence of updating.
That's a very good one. Anybody else have any thoughts? So the biggest reason is that it allows me to use different technology to modify data than what I use to read data. So let's take a second and talk about Entity Framework. So there's no denying that Entity Framework is a great framework for data, basically the cut part, right? The create, the update, and the delete with the tracking and stuff it gives you and its updating capabilities. It's really powerful and really good at what it does. However, on the read side, it's not the fastest, right? So if you compare like Entity Framework, even Entity Framework Core, raw read performance versus like raw ADO.NET, raw ADO.NET will kick the crap out of it every time. So this is the biggest reason why people start utilizing command bus and stuff anyways, is because they want command query responsibility segregation. So I can use a technology like a micro ORM like Dapper, and I can have very super fast reads, but I still get the nicety of having Entity Framework for handling my whole object graph manipulation, right? Because if you think about like Entity Framework, it not only works with the parent object, but it actually works with the entire object graph. So if a customer has orders and orders have order items, you make a change anywhere in that tree and it'll automatically pick up those changes and write it when you say submit changes to your DB context. So that's the biggest reason why that we would actually do this whole command bus stuff to begin with, is because we want to have a separation between the technologies that we use. And like I alluded to, it's because of speed. So the pattern is basically the same as what we just looked at before, where we'd have commands, we have queries, we have the bus, we have the router, which routes it to handlers. So let's look at some code with that. So let me go ahead and stop sharing again. switch back to this. Cool. All right, let me close all these tabs. Okay, cool. Let me close this stuff down. Okay, so now if you look here, just like we had before, we had commands and we had handlers. So again, we still have our command to inactivate a customer. We still have the handler for that command, which actually performs the action. And then we have the query. So again, query works just the same way as the other one, only this time it has a T because we're actually returning something back. So I'm going to create a query of customer that I want to get back the customer on. So then in here, when it works exactly the same way. I invoke my handle method and I get back my result. So one of the other things you can think about here with the handlers is think about this as an orchestrator, right? So when I invoke this handle method, I want it to orchestrate all of the work that I want done. Okay, so in order for me to, so this is kind of a bad example because it's just querying the database. So all the work I want done is to just go query the database and give me back the result. So in this case, my query repository would use something like Dapper. So if we actually drill into that repository, where's repositories? Oh, there's query repository. So this actually uses Dapper. And then all I have to do is just say, hey, open connection, get my results running the SQL that I tell you to run, and then close the connection and return me my results. So I don't know how familiar you guys are with Dapper, but Dapper is actually the database that Stack Overflow is built on. So it's meant to handle like millions and millions of like requests and stuff per second. It's super fast. And it's really cool because you have a lot of actions in here. So like, for example, like I'm taking this SQL that I want to run, select all customers. I'm telling it that I want to run a query, and then oh, can you guys still see me?
Yeah, I can see the screen, but your sound faded for a moment.
Oh, okay. I don't know what's going on with my camera.
Yeah,
so you guys can see me and hear me then, right?
I can hear you.
Can you see my screen now?
Yeah, we can see your screen. We can hear your voice.
Okay, yeah, we'll leave the camera alone then. I don't want to screw around with that. I don't know what happened. It said new hardware found or something. But anyways, so this is actually really cool. So if you guys aren't familiar with Dapper, I highly recommend checking it out because it's really cool, where you can specify the exact SQL you want to run. And then it will basically run that as a query, give you back an object that's customer. But in this case, because it's customers, I'm getting back a collection. So down here, and to show you too, because the first question you're going to ask is, what about parameterized queries? Well, yes, it supports parameterized queries too. So if we look here, where I'm going to get a customer. So again, I'm going to look at that table. I'm going to say where the ID is equal to this add ID. So as long as you say add ID, and then take the ID part, and that becomes your variable name, you can parameterize your queries to be whatever you want it to be. So that's really cool. It's a little side rant about Dapper because Dapper is what I use to do CQRS in addition to like Entity Framework. Just because it's so fast, it is like orders of magnitude faster. The other cool thing about this too, you're not seeing it here because this is this method is not showing as async, but technically this can all be async as well. So I'll show you that when we get down to our mediator examples. But I wanted to point that out too. So Dapper does support full async capabilities. Okay, so any questions about that before we move on to the command? Cool. So then with that, on the command side, we can have in whatever methods we want to do. So in this case, I'm still using Dapper just because I'm being lazy, but this could be a full-blown entity framework. And then this gives me a good separation between the two, right? So when my object comes into my handler, or my handler, let's say up here, let's say that this, the commands were attached to entity framework. What I could do is I would take the information off of the command. I would then do a lookup to find that existing customer, overwrite the information on the object graph there, and then I can just send that information off. Okay, so in that case, this again becomes an orchestrator, because whatever actions I want to do in here, such as if I also wanted to say, this.command bus .send new customer updated events. I could also do that, and then that would kick off and let other things know. So that's what I mean when I say it's an orchestrator, because whatever action needs to happen when this happens, that I want that to kick off. So the other cool thing about this is when you use this approach to laying out your software, this allows you to have these kind of events that automatically get kicked off, so that instead of having to do it back in here when you're calling it and then saying, okay, command bus, update my object and then fire off the event, it automatically will do it for you because it's in the handler. So these handlers can become very powerful depending on how you want to utilize them. They can do basically whatever you want it to do. So, and the way that you name them is you name them based upon the action you're doing. So again, in this case, I'm trying to inactivate customer. Well, when I have a customer that I want to inactivate, what all do I want to do? Well, the first thing I want to do is I want to set the is active flag to false, and then I want to save that to the database. But then I also want to, fire off this event, and then I might also want to, re-get the new customer, right? So I could say this.command bus .send new customer customer query. Oops. And then I can pass in my my customer ID. So command.customer.id. I never said I knew how to spell. So now I could do stuff like that, right? Where now, I can update my object. I can, save the changes to the database. I can now fire off this event. I can re-get the customer to make sure that I have the updated copy, and then I can return that customer back. Okay, so does that kind of make sense what I'm saying when I say it's an orchestrator? Where it can do several things, not just the one?
It's sensible so far.
Cool. Okay, so that's kind of what I wanted to show you here, is the difference between commands and queries and how you would set that up. So like in this case, if you look here where I did this customer command, this would be what they said when with the CQS. This would be a clear violation of that, because my my command should only update the state, should not return data, and my query should ever only return data. So this is more of a judgment call that you'd want to make for your application, and this would be this would be something that you have to decide, right? Are commands going to call other commands and other queries, or are we not going to allow that? Because if we don't allow that, and the only thing this does is these two lines, and I still need to do these other things here, then now this code needs to come out of there, and then it needs to get put there, right? So now something else has to orchestrate that work, right? Because I still need that work done, but now I run the risk of, well, if that customer gets updated, and there's like a couple different ways of calling into the handler, then now I'm not guaranteed for this thing to get done correctly, right? I'm not guaranteed for that update event to happen. Does that kind of make sense what I'm getting at?
Yeah, that's sort of what, ACID?
ACID in terms of like
In other words, you get control of it and set it to false, and then go on to other things.
Right, yeah, exactly. Yeah, you're not guaranteed. Yeah, exactly. So that's one of the things we could talk more about depending on how much time we have, about like different patterns and different things with that. But one of the things I do want to get into is talking a little bit about Mediator. So give me 1 second. Let me see what else we got in the slides. Yeah, okay, so let's just jump into talking about Mediator and then we'll jump back to the slides. So what Mediator is it's a NuGet package that you can add. So if we look under, packages, there you go. Yeah, so you can see it's a NuGet package that we add. And just like how we had all those things up above where we had the command bus, the command handler, the command, the query, all that stuff. And remember how I said we don't really want to have to redefine that or copy pasta that from application to application. So that's where Mediator comes into play. Mediator takes care of all that stuff for us and gives us all those abstractions and stuff to work with, and actually handles a lot of the setup work for us. So with that, so we add Mediator to that package. And again, if we look at the commands, you can see that they're the same. So one of the things with this too is remember how I said Mediator doesn't differentiate between commands and queries. So one of the things I did is, if you notice here, there's also a second NuGet package called Command Bus Abstractions. This is something I created to basically extend that to actually give you the iCommand, iQuery. But if we actually look at what happens behind that code, let me see. Let me just give me 1 second. Let me just open this folder. Oops. No, the test. No, you're here. Yeah, so if you actually look here, you can see all of my things are just, sorry, I gotta make this bigger again. But anyways, basically what you can see here is you can see that these are just request and request handlers. So see, my iCommand is just an I request. So that's all this is doing, is basically taking the default interfaces and stuff and then just giving it to you in those formats. So you can see like an iCommand is just an I request, and an iQuery is again just an I request of T. Okay, so let me switch back to the thing I was just at, and then we'll show you how to use Mediator in that. So let me close all documents. So now we have Mediator here doing the same exact thing, right? So again, we have the iCommand handler. So the code is exactly the same as what we saw before. One of the couple of things you'll notice here is that Mediator will kind of, you can do non-asynchronous, but it forces kind of asynchronous by default, which is actually really good, because like when I'm doing my updates here, for example, I want all this stuff to be asynchronous so that I can make sure that everything's working asynchronous. So having all these applications loosely wired up using Mediator kind of forces you in the direction of doing everything asynchronously, which is really good. My screen blacked out for a second. So yeah, so as you can see, all the stuff is exactly the same, right? Command is still a command, but now we didn't have to add in all that crap we did here, where we have all the command bus stuff and all the command buses and handlers and all this other stuff we'd have to copy from project to project. Okay, so what I want to show you down here now is there's a couple of things with Mediator. Let me see. No, this hold on, this isn't the right project. What I want is this one. Come on. I don't know what's going on with Visual. Give me 1 second. I don't know what's going on with Visual Studio Code now. All right, let me try reopening this. We'll see. Oh, now it opened. Okay, cool. Okay. Okay, so if we go down to here now, what I want to show you with this is I want to show you some test cases that I wrote.
Yeah, I don't have a visible display. It's just black.
Oh, okay. Hold on. Let me try resharing it again. Yeah, it's so weird. I don't know. I've never had problems trying to share my screen. I don't know. It's got to be something on my end. What was that? There it is. Okay, is that better?
Yeah, you can see it now.
All right, cool. Let me bump up the font again. Okay. So anyways, what I wanted to show you with this is kind of the code behind that extent, that NuGet package I just showed you, the mediator extensions one. But what I want to show you is how this stuff actually works, right? So how do we use mediator versus how do we use the one that we just created, right? So instead of using a command bus, it's now called a mediator, hence the name of the framework. So just equate the command bus and all the concepts and everything that we just talked about with being the mediator. And part of what's in the mediator is a message router. Okay, so everything that we had just talked about is still applicable and still exists within this library. It's just got different names. Okay, so again, mediator is just the command bus, and yeah. Sorry, I don't know what else to say. So anyways, so let's look at like one of these tests that we have, right? So here we can get a customer. We can invoke this command where I would say I want to set customer inactive. And then if you notice there's a dot command here, this is something I want to show you. This is a pattern that some people will follow. And then we invoke our customer and then we just say mediator.send, right? So that's the same thing as what we said before, where we said await command bus .send, right? It's just that now this line becomes this line. Okay, so this again shows you how we can have things decoupled, where if we're going to, like in this case, we can query, right? We could actually replace this customer with var customer equals await mediator .send get customer .query, and then pass in the ID. Okay, so we technically could do, so let's assume that we did that for a second, right? So with this, we could actually use the mediator pipeline to get the customer using the repository pattern, using whatever we need, right? We don't have to worry about all the dependency tree to wire up to get the customer. We just say, hey, mediator, go invoke this get customer by ID query, give me back the customer, and then once I get the customer, I'm going to do something on it and say, hey, mediator, go update that customer now. Go invoke that set customer inactive command. So this kind of shows you that we can have our app very decoupled, because now in order to run this code, I don't need to take in all these dependencies where now I'm taking in a dependency on Entity Framework, I'm taking in a dependency on Dapper, I'm taking in a dependency on each of these repositories, I'm taking in a dependency on whatever other classes those things are using. So now I'm very decoupled from the implementation, right? So just like the concept of when I have one app talk to another app very loosely coupled, that's now what I'm doing within my application. I have two different pieces of parts of my application that are communicating without having to take in all those dependencies. Okay, so that's where the power of this really comes into play. And yep. Okay, so any questions about that so far? Okay, cool. So the next thing I want to show you now, so again, the events are the event. So events are something we haven't really looked at yet, but I'll just show you how an event is very similar to the commands, right? So if you look at this, customer was updated.event, and we actually go look at this thing, we can see now instead of I request or I command, we're now I event. So it's exactly the same concept. The event has all the data. It's basically a POCO that has all the data that you need in order to fire off that event, because in theory, this should not have to then go do database lookups and all this other stuff. However, depending on your approach, you could. We can then have an event handler, which again has the handle event. And then what happens in this, this is actually really cool. This is something you can do that's really cool. And I can show you how we can do this at a high level. But basically, what we can have now is, if you notice this validator class that I skipped past, this is actually using something called Fluent Validations, which is a really cool framework, cool library. And basically what it says is, hey, I want to create a validator object that will basically look at this this object type. So again, I'm passing an event, which comes from up here. So I'm going to create a validator for that event object type, and then I'm going to run some rules against it. So in this case, I'm going to create a rule for the customer, and I'm going to say that the customer cannot be null. And if it is null, then say the customer cannot be null. So that's the message I want to put. So you can piggyback and do all kinds of really cool validations and stuff against your object here. And then what you can do now, before you actually run your handler, is you can actually, spin up your validator, determine if you're valid. If you're not valid, you can handle that, and then then you can perform the actual action. So one of the cool things I'll show you here in just a second is there's these things called pipeline behaviors. So that if we wanted to have this, so that every time we have an event or something like that, we want to validate the data. If there's a validator, we can build that into generic code that gets ran at the start of every pipe or of every handler, so that we don't have to. So we wouldn't have to copy and paste this stuff and then change the one line that we care about for every handler. Okay. So that's events. So as you can see, I just wanted to show you that it's exactly the same thing. Yes. Well, yeah. A validator would not necessarily be where you'd inject security, but a pipeline behavior would be where you would inject security. That would be where you could say, hey, before you make this call, I want to make sure that you have the permissions or the permissions to make that call. So yes, so that'll be in just a second with what I'll show you here in just a second. Okay, so any other questions about events before we move on? Cool. So now before we get into that, Yep. So now what I want to show you here is I want to show you how we wire this up. So in this example, I'm using .NET Core 2.0. So instead of using Ninject like we were with our command bus, this is now using the service collection. And all this code is available on my GitHub. I'll share all this with you. So if you guys want to get in and start messing around with this, this gives you a good place to start, and also a good reference if you need help. But basically what we have is we have the service collection, which is in .NET 2.0 terms. This is our Ioc container. This is just like what we saw the kernel in Ninject. So now down here, so again, I'm using a composition root pattern. This is something you don't necessarily have to do. And obviously a lot of this is because it's just like console apps and test applications here. So I do this to make it easier for someone to follow, versus like how you would actually do it if you're writing like an MVC site or something like that. So here, when this class gets called, it's going to create the collection. It's going to wire up logging. It's going to wire up Mediator, and it's going to load in any of our bindings. And then it will build our service provider for us. So if you guys, I don't know if you guys are familiar with Serolog, but I'll take a quick second here to talk to you about Serolog. Serolog is really cool too. So it's a NuGet package that allows you to add a lot of logging to your application. So for example, let's see if I can do NuGet from here. I don't know if I can, but basically what you can do is you have like the static class called log.logger. You also have an interface called iLogger that you can pass around. And what you do is at your the start of your application, you can wire up everything you want to write to, right? So I can say write to SQL Server. I can say write to file. So all I need to do is I basically install the base Serolog package anywhere that I want to utilize logging. I either use the iLogger interface instance. Whoops. Sorry, my screen blacked out on me. I can either pass around instances of iLogger, or I can use the static logger. And then all of that can be driven by the configuration that happens during composition. And then what that says is that whenever you say so whenever you would do something like this, log.logger.information. So whenever I would call this message, it's going to simultaneously write it to console, SQL Server, and to a file. And then I can enrich it with different properties. So in this case, I can say, hey, enrich with the property application name, and then it would be my application name. So this is actually really powerful logging. I actually prefer this to versus log4net because it's a lot easier to use, and it's actually a lot easier to configure. And you can actually load all this writing and stuff. You can actually load all this from configuration as well. So it doesn't have to be, just in your application. Okay. So any questions about Serolog before we go on? Okay, perfect. All right, so now let's talk about how we wire up Mediator. So if you notice here in my application, I have my commands, my queries, my events. I have all this stuff right here, right? So like my set customer inactive. Actually, sorry, that's this is up under my application. Yeah, so if you look under here, let me close some of the stuff down so you can see what I'm looking at. All right, so under my application here, I have my commands, my queries, my events, right? So with this, what I need to do is I need to figure out what the application here is, the assembly name, and then I pass that into Mediator to tell it where to look for my commands and my handlers, right? So this is one of the niceties about Mediator is I can say, hey, Mediator, so at service collection.add Mediator, which is an extension method that they give us by using that package, and then go look for this type, so type of this type, and then pull the assembly. And what this will do is this will automatically scan that assembly or assemblies, and then it will find all the instances of command of I request handler, I command handler, I query handler, I event handler, and it will automatically wire all that stuff up for me, so I don't have to do that stuff manually, right? So I don't have to have like 100 lines here because I'm having 100 different handlers, right? So that's one of the niceties that you get out of using Mediator. The other thing you can do here, which is you can see I have this commented out, and I did have a demo I was going to show you in Visual Studio with this, but basically what this will do is we can add what's called pipeline behaviors, and this is stuff you want to happen either before, during, or after you make the call to your actual step, into your actual handler, right? So for example, if you wanted to add logging, where maybe I want to log, so like in this case, I want to log what's going to happen during the process, I can add logging that will happen around every step. So that way I don't have to, pollute my code with pollute each of my handlers doing that logging stuff for me, or I don't have to pollute my handlers by doing that logging stuff every time. This would also be where you could do things like security. This would also be whatever other things you want to happen at each step of the pipeline. So also with the pipeline behaviors, there's actually a way with these. I haven't used it very often, or actually ever, but I do know it exists. But you can actually overwrite the pipeline itself and actually have it dictate and do different things. I don't really recommend doing that unless you really need to, because I would say that 98 to 99% of the time, you can accomplish that just by using the raw handlers and or the pipeline behaviors. Another is having. Yes, exactly. Yeah, so another example would be is like if something fails, I can have it handle those type of failures. Yep. Yeah, so for example, I could have a behavior that says like, okay, if we got a SQL error or through any kind of exception, then we can have that handle the exception and then do that. Yep, exactly. So let's take a look at what this logging behavior does. So again, if you look here, I'm using Serolog to create an instance of iLogger, or to get an instance of iLogger. In this case, what I'm doing is I'm just pulling the log.logger. I could just as easily do iLogger. In general, I prefer with Serolog, this is more or less like me, I prefer using the static class of log.logger versus having to inject my dependency of iLogger everywhere, because that gets really ugly, because anything you want to add logging to, any class or whatever, you now need to add that interface, and it just gets really ugly. So that's why in general I tend more towards the static class. And in order for that static class to work, you have to make sure that you initialize it to that. You have to initialize it to something. So in this case, I'm going to create my configuration, and then at the very end, create my logger. This is going to take my instance of iLogger and then set it to that logger, log.logger. Doing this initialization right here is what allows me to actually just be able to use that there. So in this example, you can see here that what I'm going to do is when I get a request in, I'm going to then do something with it, right? So I'm going to log a message that says I'm going to handle, then I'm going to do this line here, and then I'm going to say that it handled it. So what this await next does is this actually calls the step in the pipeline. So if you think about this as as controlling the step of the pipeline, right? So this would be my before action, this is my during, and then this is my after. So this is how you can actually do that, where you can control the actual flow of what's actually going to happen there. So before anything happens, I can say, hey, I'm now calling into this method. And then, yep, okay, so now I got a response there. So if you wanted to catch exceptions, for example, all you'd have to do I do not know what that was. So all you'd have to do is something like that. And obviously this would have to go in here. Right. Okay. So you could do like, yeah, to handle your thing where you want to handle like errors, all you'd have to do basically is do a try catch, put your call to next in there, and then handle whatever you want to handle in there. So that would be another example of a pipeline behavior you could add. And by doing those and wiring them into your mediator pipeline here, those things will happen automatically for you. So like going back to your example of doing like permissions and ensuring you have access and stuff like that, you could have mediator chop that off and not have to handle all that permission checking stuff all the way down down in your application. Does that make sense? Thinking about credentials management along the path of any service handlers.
That seems sensible to me. I can see how it can get more complicated as you add all that stuff in.
Yeah, it can. Yeah, I mean, and you definitely want to use the stuff sparingly. But if there's definitive stuff you want to do at every step, then pipeline behaviors are definitely the way to do it. And it's just like SQL, right? So think of it like SQL. So if I want to pick all the columns from the table, I can say select asterisk from. If I want to pick anything other than that, then I have to specify everything, right? Every column that I want to pull. Well, that same thing is happening here. So you would only use pipeline behaviors if you want to ensure that it happens for every step in the pipeline, and not get into a situation where like, well, I got this thing for the pipeline, but it only happens under these 3 conditions or whatever. Does that make sense?
Yeah, it makes sense. I was thinking about healthcare, like with the HIPAA, that all information is not available to every viewer.
Yeah.
And so, depending on who it is, what do they get to look at?
Yeah, you can do stuff like this too. You can do stuff like this too. Whoops. I would try to stay away from doing stuff like that. But you could do that too, like where maybe you want this thing to apply, but you only want it to apply to certain handlers. Especially now with if you do it like how I just did it here, where it's like magic strings, you would actually want these to be something better. But anyways, so you can do that kind of stuff as well. But in general, when you're doing pipeline behaviors, you want it to apply to everything. Cool. Any questions about Mediator before we go back? I know we're probably a little bit over time. Is there anything else you guys want to see or any questions you have about Command Bus, why we would do Command Bus, CQRS, Mediator, anything?
We've done a lot of research on peer-to-peer stuff, and this seems like a way to develop generic ways of handling systems with a lot of different handlers in them. The ones I've been working on are across the internet.
Yeah, and again, that's the biggest thing to keep in mind with the Command Bus. The Command Bus is only for across different parts of your application, not across different applications. But yeah, but as you can see too, like if you get used to using the Command Bus and you've never used like a message bus, once you get used to the patterns and stuff with the command bus, it's exactly the same with the message bus, except that you're now writing to something different. So it's not running in process, but the concepts are all exactly the same, right? I'm going to create a request that I want to put on the queue, throw it on the queue, and then on the other side, I can just pull it off the queue.
Well, it's here or there. You could also use this for a distributed management, pattern, if you will.
Yep.
That could easily go across the internet.
Yep, exactly.
I saw another one where they're actually controlling a small satellite from their cell phone.
Wow, that's crazy.
Yeah, well, it's the nature of things. NASA put up an internet in the sky.
One second, I'm gonna try switching back to the slides. I don't know why this thing's doing this. Come on, where's it at? Now it's not even showing me all the tabs. All right, that's weird. Yeah, it's sorry for the technical difficulties. I don't know what's going on tonight. Like, I've never had problems like this.
Maybe it's an update to make it work better.
Probably. Yeah, it's probably Windows update, which means it broke it. That's usually my experience with Windows updates.
Wouldn't be the first presenter that had that problem.
Yeah. I mean, this application is literally not in here. Why is this not? Anyways, let me just talk to you about the last things. So basically, there's some couple things I wanted to leave you with is some pro tips. So when you start introducing command bus architecture into your applications, you have to be very deliberate about how you do things. So like you should still follow good practices like single responsibility principle, not having God classes, things like that. And you want to make sure that your commands have very specific names. So even going back to the thing I talked about earlier, where should we have a command that calls other commands? Like maybe we update customer, but then does it then go update orders and then go update, order items, things like that. That's going to be really a decision you're going to have to make. So I've actually talked to Jimmy Bogart in depth about that. Jimmy Bogart's the creator of Mediator. And he said that that's one of the things that they would debate as well. So basically, you have to figure out where you want to draw your line in the sand, and how that would work. Because yeah, so handlers are a one-to-one to a command. So there's one command goes to one handler. And whether they call others or not is up to you. So I think that you can do. Yes, it is open source, and so is my Mediator library, the command bus abstraction part of it. Sorry, what was I saying? Totally lost my train of thought. Sorry. Oh yeah. So another thing you want to do is you want to develop your own naming convention. So if you notice that mine was inactivate customer command versus just update command, update customer command. So what another recommendation that Jimmy talks about is that when you create these commands and your queries and stuff, they should never really be changing. So for example, like let's say you have an application that's going to have different ways of inactivating a customer. And then using it in this screen versus that screen where maybe you're passing in some other contextual information. What you would do is you would create new commands instead of trying to make that one command handle both scenarios. And by doing that, one of the benefits you gain is that now you know all your stuff still works, right? So now you're just adding new functionality. You're not risking breaking existing functionality. So now you can duplicate a handler, give it a new name, let's say inactivate customer from customer edit screen command, and then you can have your new functionality there. So there's pros and cons to that too, because if you think about it, now you're going to have a lot of classes that do very similar things. So it's all up to you as to how you want to architect your applications around, do you have that level of granularity where now you're just always adding new commands instead of changing them? So basically think of it as the open close principle from Solid, where I'm open to creating new commands, but I'm closed for making modifications. And then that way you can ensure that your application is not going to break. So that's one way that you can do that, especially if you're working with some junior developers. You can institute a rule like that. But just know that that also comes with some overhead where now that code could get outdated or whatever. Let's see what else. Okay, so that's basically all I had with this. I do, if you go to github.com/Korz, K-O-R-Z, I'll put it in the chat here. That's my GitHub page where I have all the slides and all the code and everything. And I'll also put my Twitter handler here. So if you have any questions, feel free to reach out to me. So hopefully that was pretty informative for you and not too confusing. So if you guys have any other questions, I'll take them now.
Well, just thank you, and it's very interesting. I'll go over to the GitHub and see what we can interpret that.
So this is Joe. A simple question.
Sure.
Has .NET Core really changed this guidance in any way?
Change the guidance in terms of what, like using using command bus in general?
Yeah.
No, I don't think it has.
What you're advising, right?
No, I don't think it really has. So a mediator is still really relevant because .NET Core is really not doing anything in your application to kind of dictate or kind of help you out with the kind of architectural things that this is providing. So like, for example, like CQRS, right? There's nothing in .NET Core that's saying, here's CQRS, right? Here's the pattern for following CQRS in .NET Core. What it is doing is it's giving you built-in like dependency injection. So now instead of me having to add like ninject, I can use the service collection stuff that's built right into .NET Core. But other than that, no, I don't. .NET Core is not making any of that irrelevant or outdated. Hopefully that answers your question.
It does, and I appreciate that because I think that's one of the things a lot of people, wonder is whenever they encounter something a little bit new or different, like they're like, well, how does my framework impact that? So I think that's important.
Yeah, and that's why I was trying to show you too with the first examples are .NET 4.6.2, and then the mediator example was actually .NET Core 2.0, which I know is now outdated, but at the time that I wrote that mediator command bus abstractions repo, that's what I was using. So, and feel free to check that out too. I'll send you a comment, or I'll send you the link for that if you actually want to see the code and everything that I was doing behind the scenes with that. And like I said, it's just very thin wrappers around mediator. And the only reason why I didn't put it in the mediator application, like submit a pull request, is because I didn't want to pollute that code. But at my previous job, there was a lot of kind of sticks in the mud, if you will, where people were like, well, mediator doesn't do command bus and there's no command and no query. I'm like, well, that's because mediator doesn't care about it. It's just I request. So they were getting really confused by that. So I'm like, all right, here's what I'll do for you. I'm like, I'll create an I command, I'll create an I query, but at the same time, I didn't want to pollute mediator with that, but I did want to give people the ability to do that if you know, if you're starting out with command bus and you're still trying to get used to the stuff, and it's easier for you to say, I have an I command handler, I query handler, then it's probably easier to follow those abstractions, and then eventually you could probably, you know, wean yourself off of it. So
Okay.
that's why I did that. There was one other thing I did want to show you though. Give me 1 sec. Let me share my screen again. If you guys have other questions too, you can go ahead while I'm getting this back up. Okay. So one of the other things that you'll see too, and this is a completely optional up to you. But if you remember back here, I said this dot command. So if you look up here, this commands, and I see like it's just called set customer inactive. So one of the things that some people will do is they'll put all this stuff in one. So since it's a one-to-one between a command and a handler anyways, then it just makes sense to kind of put them in the same location instead of the command is way up here in this folder, the handler is way down there in that folder. Because if you have a pretty large application where you're trying to use this, and those two things are pretty far apart, then it becomes a pain in the butt to work with. Because 99% of the time when you need to go to either the command or the handler, you're going to need the other. So if you're in the handler and you need the command, you're going to need the command. Or like what's even worse is when you're in a command and now I need to go to the handler. Now what I need to do is now I need to say, you know, Control F, find me customer. Customer handler, and then I'd have to search for my code and find the instance. Like it's a pain in the butt. So this is a pattern that I started adopting. In general, I don't necessarily like nested classes or multiple classes in the same file because I think it makes things hard to work with. But in this case, I'm okay with it because I'm limiting the functionality of this. So that way I have everything right here that makes it a lot easier to work with. Okay, so that was one of the things I did want to show. Sorry, is there any other questions?
I got a real tough question for you. Have you ever seen anybody doing anything like this? You know, even in a different setting, but maybe just a different idea, a different approach to the same problem set.
You mean other than using like command bus? Like what would be another way of doing that?
Right. Yeah. In other words, using the library set here. Are there any others who are speaking to this kind of meta issue?
Not that I'm aware of. I mean, there is other frameworks. There's like a event flow and stuff that do similar things. You know, each framework has their own pros and cons. I tend to like Mediator because it's really fast and it's really straightforward to use. And the reason why I do it, like I said, more than anything is CQRS. So like you can use Mediator outside of CQRS. Like if you want to use it to just decouple parts of your application and have things really loosely coupled and you want to handle this message routing, you can do it. I mean, you obviously can do it without using CQRS examples. But CQRS is the main reason why somebody would use a command bus.
Okay, so in other words, it's a little more refined concept than the others that have been out there.
Yeah, exactly. Yep. Yeah.
Right.
So Mediator is it gives you all the structure, but it doesn't necessarily pigeonhole you into you know, one way or another. Like for example, like Mediator doesn't say you have to nest your classes if you really don't like that. This is just more or less something that we've adopted from my 7+ years of using Mediator, and it's something that I highly recommend you consider. Just because, like I said, 9 times out of 10, you're going to be back like here. You're going to say, hey, set inactive customer command. If this was without the period, and now I'm going to have to go find that command. You know, now I go to the command, and now I would have to go find. Now I have to go search in my code for that handler, and then I'd have to find the class, which is a major pain in the butt versus just going F12 and being there.
Right, so the container has everything needed, and you just go and fish it out of there.
You talking about the IOC container?
Well, well, in a sense, I view command as a container. You know.
Oh, yeah.
Good stuff, Brian. Definitely enlightening.
Sweet. Yeah, and if you guys have any questions when you start getting into it, feel free to reach out, because like I said, it's all architectural patterns, and I'm trying to convey to you the not only the concepts of what's contained within it, but kind of why you would want to use something like this. Because obviously it's not a use case for everything. Like, right, if you're writing an application that for some reason doesn't use a database, which is highly unlikely, but if that's the case, which is a lot of case in my aspect, because I do a lot of machine learning work. So a lot of my stuff is not using database. So I don't necessarily use it for that. But one of the things that I have done with Mediator is I've actually turned it into a generic pipeline, and I actually use Mediator to create a pipeline to actually execute my machine learning models. So that would be another example of where you could use that outside of just the CQRS use case. So it's basically anytime you want decoupled routing of messages across your application for whatever reason that would be. Cool. So that's all I have.